Hello students, I welcome you all to the discussion of yet another important module of the chapter Electrochemistry. And in this module, we are going to discuss about types of conductors, of which one other type I have already told you in the previous module, right? In this module, we are going to focus on electrolytic conductors. So let us start with a discussion with the electrolysis of molten NaCl. So here we take an electrolytic cell containing molten NaCl dissociated into Na plus and Cl minus ions. There are two electrodes which are dipped within this electrolyte. These two electrodes could either be graphite electrodes or platinum electrodes, which are precisely inert electrodes. These two electrodes are connected through a battery. Alright? So basically we have a negative electrode and positive electrode, namely cathode and anode respectively. Alright? So students, when the current passes through this electrolyte, the ions, they get attracted towards their respective electrodes. Alright? So Na plus will be attracted towards cathode, Cl minus will be attracted towards anode. And in this process, the negative terminal of a battery acts as electron pump. So it pumps the electrons within this electrode. So have a look here. Electron will enter the cathode. Na plus ions will take up this electron and will get reduced to sodium metal. So if I want to give you all the reduction, half reaction here goes like this. 2 Na plus liquid state, students, molten state, plus 2 electrons giving us 2 Na solid, right? At the same time, chloride ions at the anode, they lose their electrons and they get converted to chlorine gas. So the released electron will enter the battery through a positive terminal, and these chloride ions will get converted into chlorine gas. Okay, so at anode we basically have liberation of chlorine gas. So if I now want to give you all the half reaction for oxidation of chloride ions, goes like this. So you have 2 Cl minus liquid state giving us chlorine gas with 2 electrons. So these are the two half reactions taking place at the respective electrodes. So students, what is happening here actually? The electron transfer is taking place by migration of positive and negative ions towards the respective electrodes, right? So here basically electron transfer way is different than what we had seen in electronic conductors, right? So what is happening here is the conduction is involving the transfer of matter. The conduction is involving what? Transfer of matter, isn't it? And because of the transfer of matter, there is going to be a chemical change or chemical reaction observed, right? So the current flow here is always accompanied with chemical changes. You can clearly see that here molten NaCl is decomposed, or you can say it is electrolyzed. Alright, I hope this is very much clear to you all. And now to give you all the idea with respect to effect of temperature on the conduction in case of electrolytic conductors, it goes like the resistance will decrease. Resistance, if it is decreasing, so obviously conductivity is going to increase, right? With increasing temperature. So this is the effect of temperature on the conductivity as far as electrolytic conductors are concerned. So let us quickly define the electrolytic conductors. The conductors in which conduction takes place by the migration of positive and negative ions, they are known as electrolytic conductors. And to define electrolytes here, we can simply say that the substances which produce a conducting solution in their aqueous or molten state, they are known as electrolytes. Alright? And electrolytes here, on the basis of degree of dissociation, are classified into two broader categories. One is strong electrolytes, another one is weak electrolytes. The strong electrolytes completely dissociate or almost dissociate, whereas weak electrolytes do not undergo 100% dissociation. Alright, so examples of strong electrolytes were ionic salts, strong acids and bases. For weak electrolytes, it is weak acids and weak bases. So I hope you have got a clear understanding of electrolytic conductors as well, right? So let us quickly differentiate between electronic and electrolytic conductors, alright? So the very first point with respect to electronic conductors says that the flow of electricity occurs by the migration of electrons through the conductor, right? Whereas in case of electrolytic conductors, the electron transfer takes place by migration of positive and negative ions towards the electrodes, right? That was the first point of difference between electronic and electrolytic conductors. Next, the conduction does not involve the transfer of matter, whereas in case of electrolytic conductors, we have seen that the conduction involves the transfer of matter, right? Next point, the conduction process does not involve the chemical changes, whereas we have just now seen that here in case of electrolytic conductors, the current flow is always accompanied with chemical changes. And finally, there is one more point of difference. The resistance of the conductor increases and conductivity decreases with increasing temperature as far as electronic conductors are concerned. Whereas in case of electrolytic conductors, resistance is going to decrease and conductivity is going to increase with temperature. So that was the differentiating points between electronic and electrolytic conductors. So I hope students you have got the clear idea with respect to this module. Thank you all.